Hello. In this lesson, we are going to be learning how to figure out the total resistance for a parallel circuit. So let's begin. So in a series circuit, if we recall, if we had a 2 ohm resistor and a 3 ohm resistor and a 4 ohm resistor, and we wanted to figure out the total resistance, the RT of that circuit, what we would do would be we just would add them up. So 2 plus 3 is 5, and 4 more, that would equal 9 ohms. Relatively easy. We just figure out what the resistors are and add them up. In a series in a series circuit, it was that easy. But in a parallel circuit, it's a little bit trickier. So if you remember back how we added capacitance in a series circuit, that is the exact way we're going to do it in here. So what we're going to do is I'm going to pull up a calculator and we're going to add these up. So actually first I'm going to just write it out. So what we're going to do in our calculators, we're going to type 100, and then we're going to hit the 1 over x button, and we're going to hit plus, and then we're going to hit 200, the 1 over x button, and then we're going to hit equals and 1 over x for one last time to give us our amount. So if we were to do that on a calculator, it would look just like this. So I'm going to pull this calculator up. We're going to hit 100, 1 over x, plus 200, 1 over x, equals, and then it's so important that we hit that 1 over x button again. And that's going to give us 66.666 forever. So our total resistance for this will be our RT will equal 66.66, and then we'll just say 7 ohms. So now we have our resistance total. When we have our resistance total, we can then find our amps total. So to do that, so we find our amps total. So our amps total would be right here. That's 8 RT, and our amps total would equal, so we'd have to have a source voltage for that. So if we have a source voltage of, let's just say 10 volts, we would get our resistance and divide it into 10 volts. So again, we grab our calculator, and then we would, I'm going to paste this up here, we would get our 10, and we would divide it by 66.66666, and then we'll throw a 7 in there. And we're going to hit equals, and it's going to come up with some really crazy number here. So we're just going to round this to 0.15, because if we go back to here and go back one more, it's going to give all these a 1, and it's going to be that. So we're going to say 0.15 is our amps for this. 0.15 amps. And then if we wanted to find the amps for each branch, we would do the same thing. So we know that we have 10 volts going across here. Make that a little smaller. So we know we have 10 volts going here. And we know we have 10 volts going across here. So we can figure out the amps for each branch also. So if I got 10 and I divided it by 100, I'll get the calculator out for that. So I got 10 and then I divided it by 100. It's going to give me 1,000. And that's totally not right. Let's clear it. I must add something in there. Let me clear that out. So if I had 10 and I divided it by 1,000, or geez, 10 divided by 100, there we go. That's the answer I was looking for. The answer is 0.1. So across R1, it is 0.1 amps. Now, we know that Kirchhoff's law of amps says that our source amps are the amps we start with. Our total amps is 15. That if we add up all of the amps in all the branches, so say this branch right here, the R2 branch, and then the R1 branch, if we add up the amps in both of those, it should equal our source amps. So if we get 200, for our 200 ohm resistor, we get our 10, and we divide it by 200, we should get 0.05. And if we look down here, for R2 equals 0.05 amps, and 0.05 and 0.1 together, both of these together equal that. So we did it right. So I hope I didn't confuse anybody. We're going to do one more. So here we go. Now there's 3 different resistors in this circuit, in this parallel circuit. So we're basically going to be doing the same thing. We got the one here, the one here, and the one here. So first thing we're going to do is we're going to find our resistance total, and then we're going to find our amps total. That's going to be if we put a little amp meter right here, and then we're going to find our amps across R1 and our amps across R2 and our amps across R3. So the thing we got to watch out here is that there's a K there, which means 1,000. So let's not forget about that K. So to do this, we're going to have to find our resistance total. So what we're going to do is grab our calculators again. And we're going to clear it out so we don't get any ghosts like we did last time. And we're going to get 9 volts. And we're going to divide it by 10,000. 10, 1, 2, 3, 4. So there's our 10K, there's our 10K. I'm going to hit equals. And that's going to give me my amps right across here. So my amps, so we can do this a couple ways. I'm kind of doing it, should have explained to you what I was doing before I did it. So the amps across resistor 1, amps across resistor 2, amps across resistor 3. I wanted to do this one a little bit different than the other ones just to show you that there's many ways we can do this. So it is 0.0009, and that's across R1. So 0.009 amps. One more 0. I'll just sneak it in there. 9 amps. Now we're going to find out the amps through R2. So again, we have R9, and we're dividing it by 2,000 this time. 2, 1, 2, 3, equals, and that's going to be 0.0045. 0.0045 amps. Now we're going to do our last one, which is this one right here, R3, and we're going to get our 9 volts, and we're going to divide it by 1K, so that's 1,000. 1, 1, 2, 3 equals, and that's just point and 2 zeros and a 9. 0.129 amps. Now, if we add these up, they're going to equal our amps total. So if I get 0.9, if I get this number right here, 0.009 plus 0.0045 plus 0.1239, and that equals, my amps total is going to be it disappeared a little too quick, 0.0144, 0.0144 amps. Now we can double check that, so I'm going to put a little slash here. So let's find our total resistance. To find our total resistance, what we're going to do is we're going to get 10,000, and we're going to 1 over x it, plus 2,000, we're going to 1 over x that, plus 1,000, we're going to 1 over x that, and then we're going to hit equals and hit 1 over x again for our answer. Again, don't forget that last 1 over x. So we're going to type in 10,000, 10, 1, 2, 3, 1 over x, plus 2, 1, 2, 3, 1 over x, plus 1, 1, 2, 3, 1 over x equals, and then here's that last 1 over x, and it gives me 625. So my resistance total is 625. 625. Now if I want to find my amps total, which is right here, all I got to do is get my 9 volts, Ohm's law, we're going back to Ohm's law, we're going to get our 9 volts, and we're going to divide it by 625. Divided by 625, and I hope it's going to be our amps total. Bada bing. Yep, exact same number. 0.0144. So there's 2 different ways right there we can find our amps total. We can do each branch and then add them up, or we can do the resistance total divided into the volts total. And that's about it. If you have any questions, of course, grab a hold of Mr. Haynes and he'll help you work it out. Thank you for watching, and I hope you learned something.